Hello friends, this video on Inverse Trigonometric Functions Part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 and Part 2. So let's find the inverse of sine function first. The natural domain and range for sine function is from R to minus 1 to 1. So if you see the graph, this is how the sine looks like. So you can take any real number. This, if you see this graph, this is you can take any real number. The x-axis, it can take any real number, but the y-axis, if you see, the maximum value is 1 and the minimum is minus 1. So this is minus 1 to 1 and this is all real. Now if I want to restrict this to an interval such that I get all unique values, what I can do is, if you take 0 to pi range, you see that for this and this point, the output is same, correct? Because if you draw the line, the output is same, so it won't be 1 over 1. So we can't take 0 to pi. Got it? Why we can't take 0 to pi? Because if we take 0 to pi range as a domain, you see that two values, maybe I think here it is some value, I think is pi by 4 or something. It's pi by 4, and here it is pi by 2 plus pi by 4. This value, both have same value of sine. So if you see this, sine pi by 4 is nothing but 1 by root 2, and sine 3 pi by 4 is also 1 by root 2. So both these values, pi by 4 and 3 pi by 4, lie in this range. So we can't take this. If you take this, it won't be a 1 over 1 function. So let's try to take this one from pi by 2 to 3 pi by 2. So if you take this, if you see, all the values are unique. So you can take these also. But the one which we take generally with the natural is minus pi by 2 to plus pi by 2. This is the natural restriction. See, if you take this also, it becomes 1 over 1 on 2. If you take this also, it becomes 1 over 2. Why? Because all the value in this are unique. All the value are unique. For any x, if you see, you can't have two. For any 2x, you can't have two same y. So minus pi by 2 to pi by 2 is also one valid domain. Plus pi by 2 to plus 3 by 2 pi by 2 is also a valid domain. You can see. So there are multiple valid domains you'll find for which the function can be inverse. So for the natural one, we will take minus pi by 2 to plus pi by 2. If you take this, the function becomes 1 over 1 and on 2. You see, if you restrict this to minus pi by 2 plus pi by 2, this becomes 1 over 1 and on 2 with range. Now we have to restrict the range also. Range is minus 1 to 1. So in this whole thing, if you restrict the range to minus 1 to 1, and if you restrict the domain to minus pi by 2 to plus pi by 2, the whole thing becomes invertible function, because that becomes 1 over 1 and on 2. If you take any value in this domain from minus pi by 2 to plus pi by 2, it will give a unique value only. So if you see, the restricted domain and range for this sine function is minus pi by 2 to pi by 2. This is the domain, and the range is minus 1 to 1. So in this case, it is a 1 over 1 and on 2 function. So it is invertible. So if you flip this, if you inverse this, if you find the sine inverse, you have to just flip this. So this becomes the range becomes domain here, and this becomes the domain becomes range here. So what we got for the sine inverse function, restricted domain and range is minus 1 to 1. This is my domain, and range becomes minus pi by 2 plus. So as I have told that if sine is restricted to any of the interval minus 3 pi by 2 to minus pi by 2 or pi by 2 to 3 pi by 2, all these will give you one set of inverse function, because all these set, if you see, are 1 over 1 and on 2. But minus pi by 2 to pi by 2 is called principal value branch. Please note, this is called principal value, and these all branch, if you see, minus 3 pi by 2, this will be somewhere here, I think. Yeah, this one to minus pi, this one. All these, if you see, these range are normal intervals. There are normal intervals for which the sine value are 1 over and not 2. But this particular one is called principal value branch. There are so many branch for this. The sine function is invertible. Minus pi by 2 to pi by 2 is called the principal value branch, and the other branch are called normal branch. Also, if y is equal to sine inverse x, then sine y is equal to x. Please note, if you say y is equal to sine inverse x, then sine y is equal to x. Just a convention, you should note this. When you say y is equal to sine inverse x, you take sine inverse here, so this becomes sine, so the sine y become x. So let's understand the graph of sine inverse function. So we got the sine inverse, so we can form the sine inverse graph also. So if this is y is equal to sine x, you see this becomes y is equal to sine inverse x. How? We just topple it. So if you see this, here the y-axis contains minus 1 to 1, and x-axis contains all this minus pi by 2, plus pi by 2, all these values. We just toppled it. Here the y-axis contains all these values, minus pi by 2 pi, minus 2 pi, minus 3 by 2 pi and all, and x-axis contains minus 1 to 1. Just flip it, that's all, and you get this graph, and this graph is nothing but my sine inverse x function. Now if you add these two, so this guy is actually, if you see, is obtained by actually finding the values. Y is equal to sine inverse x. We have plotted the values, we got the values, and we have plotted it, and we found this. So this was done by actually finding the values of y is equal to sine inverse x. By putting different values, minus pi by 2, pi and all, we got this graph. Now after plotting this graph, we observe that this is nothing but a mirror image of this graph along y is equal to x line. So let's see this. So graph of the inverse function is also obtained by getting the mirror image of the original graph along y is equal to x. So this is my original graph, y is equal to sine x. To find the y is equal to sine inverse x, you just have to draw this y is equal to x line and just get the mirror. So if you get the mirror of this line, mirror of this along this line, what you will get is this graph, and this is nothing but y is equal to sine inverse graph. So this is what we observe, that sine inverse graph is nothing but mirror image of sine graph along line y is equal to x. So that is all about sine function. What we observed, that the sine function was not 1 onto over the natural domain, because natural domain and range, natural domain was all real number and range was minus 1 to 1. It was not 1 onto. What we did was, to make it invertible, we restricted the domain and range, and then we found that by restricting the domain and range, we made the sine function invertible. And then we drew the graph of y is equal to sine x and y is equal to sine inverse x, and then we observe that the graph of y is equal to sine inverse x is nothing but the mirror image of y is equal to sine x along line y is equal to x. Now let's do the same thing for cos x. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.